Hello everyone, and welcome to 8th Guwahati MuleSoft virtual meetup. And the topic for our session today is implementing one-way and two-way SSL for MuleSoft application. The organizer for this meetup is Vaishnavi and myself. So, Vaishnavi, would you like to go and introduce yourself?
Yes, hello everyone. I'm Vaishnavi and I'm working as a senior lead engineer for Epicero. And I have almost around 5 years of experience in the integration domain.
Thank you, Vaishnavi. Hello everyone. Hi, this is Abhishek. I am a MuleSoft ambassador. I am working as a SSL solution architect in Epicero. I'm a certified developer and architect. Overall of 7 years of experience and 5 years in MuleSoft. So that's all about me. Now let us talk about the speaker. So our speaker for today meetup is Shyam. And thank you, Shyam, for taking the invitation and all the best as this is your first meetup as a speaker.
Yeah, thanks,
So
Abhishek.
yeah, over to you.
Yeah. So I'll share my screen. So
You can introduce yourself and
yeah.
then I will have some save Harvard and home
Okay. Sure.
housekeeping and then we can take it.
So hello everyone. I welcome all to this Guwahati MuleSoft meetup. I am Shyam Kulkarni and I'm currently working as a senior software engineer at Epicero. I am a MuleSoft certified developer and I have like only 1 year of total IT experience. I joined Epicero as a fresher and then continued with my MuleSoft journey. So yeah, this is all about me.
Thank you, Shyam. So before we start, some safe harbor statement. So let me read it out. So both the speaker and host are organizing this meetup in individual capacity only. We are not representing our companies here. This presentation is strictly for learning purpose only. Organizer or presenter do not hold any responsibility that same solution will work for your business requirements. This presentation is not meant for any promotional activities. Some housekeeping. So a recording of this meetup will be uploaded to the YouTube page, YouTube in 24 hours, and will be set up in the page within 24 hours. So you can go and you can check out the page in next 24 hours. You will get the glimpse of today's meetup. We have given access to most of you for mic. So if you have any question, please feel free to ask to the speaker or the organizer or anyone who is in the meetup. They can answer, they can ask any question. So feel free to ask your doubts over here. Let us make it more interactive. And the last one and the important and my favorite one is the feedback. So we'll request you to please give us the feedback for our session. You will get a mail once the meetup is over where you need to give your feedback, where you also give your suggestion for the next meetup topic which you want. You can suggest that, you can give any feedback if you want, and if anyone want to nominate themselves, they can reach out to me or any organizer from the community and we'll help you with the topic and organizing a meetup for you as a speaker. So over to you, Shyam. I will just stop sharing and you can
I'll
present.
Yeah. Let me know once my screen is visible.
Yeah, sure.
So are you able to see the PPT?
Yeah, it is visible.
Okay. So hello everyone. So today our topic is on like implementing one-way and two-way SSL for MuleSoft application. So our today's agenda will be understanding what is SSL TLS, what is key store and trust store. Then we'll see what is encryption and its two types, that is symmetric and asymmetric. Then how we can ensure the integrity of data using the digest or hash. Then we'll see what is a certificate, and then we'll move on to our last part, that is demo of one-way SSL and two-way SSL. So like first we'll go through some fundamental concepts which collectively combine form the basis of one-way and two-way SSL. So originally this SSL was developed by Netscape Communications, and in simple terms, if we look about SSL, so SSL stands for Secure Sockets Layer, and it is one of the security technology which is used to establish a secure connection between web server and web browser. So this secured link, right? So this secured link is in encrypted format, and so it assures the users that data which is being passed between this link, that is between web server and web browser, it remains private and original. Okay. It is SSL is an industry standard protocol which is being used by several websites for protecting their online transactions with their customers. But the main role of SSL is to offer security to the web traffic. And in this security, what elements it includes, right? So it includes confidentiality, the integrity of message, and authentication. So since this word, that authentication word came, right? So just wanted to put a point. So like gaining access to any digital resource. So it is a three-step process, which we call it as IA and A. So I stands for identification, like who are you, and authentication is like prove it, and authorization is whether do you have the permission to access that or not. So this authentication includes providing a password, or like we have a fingerprint, right? But it is important to understand that this step, the authentication step, this doesn't occur in isolation. It is preceded by an identification, that is entering your username, like validating your username, and it is being followed by the authorization. Example can be like access denied, right? Now these elements of security is achieved. These elements of security means this confidentiality, integrity, and authentication. This is achieved by SSL with the help of what? So it is achieved with the help of cryptography, digital signature, and certificates. So SSL is deprecated, and TLS is used currently. Now we'll see like how on a like a basic overview how SSL works. So SSL consists of two distinct entities, and we call it as client and server. So the client is the entity which starts the transaction, and on the other hand, server is the entity which responds to the client and it negotiates the cipher suites. Okay, and it also do negotiate that which cipher suite will be used for the encryption. Now, what is a cipher suite? So it is a set of protocol which is to be used in TLS communication. So like that protocol could be like the symmetric key encryption algorithm. We'll see about symmetric key encryption algorithm as we progress. Okay. Now, what is the SSL handshake? Now, in this protocol, server is always authenticated by the client, and server also consists the option of authenticating the client. Okay. So, if I want to summarize the SSL handshake process, so firstly, the session capabilities are negotiated, means the encryption algorithms or the cipher suite is negotiated, and secondly, the server is authenticated to the client. So, so in this diagram, you can see how this process occurs. So first, the client sends the client hello message. Along with that, he sends the SSL or TLS version, the cryptographic algorithm that is being used to encrypt the message, and the data compression methods being used. Now, as this message reaches to the server, server responds with a server hello message, and then there happens a cryptographic algorithm agreement. Session ID is exchanged. Server shares its digital certificate, which is being present in its own key store. It fetches from that, and that certificate is also uh, like that certificate also contains its public key, server's public key, and then the client key exchange happens, and then finish client message occurs, and then there is a finish server happens. Okay, in between that, uh, when the server sends its digital certificate, right? So client has to verify it. So how it will verify it? It will look at its own trust store, right? Which is like a list of all the trusted certificates, right? And then it verifies its genuineness. Okay. So we'll see what is a key store and trust store. So this name only represents, right? So it will store the private key and associated certificates having the public key. Now this key store is having its own password. Okay. The certificate resides inside the key store. So the owner, so here in case like we saw, the owner was server. So server will retrieve its certificate from its key store, and it will present it to the other side. Now trust store. So trust store, the name itself says, right, something which is like trustworthy, where we can like trust. So trust store is having a list of all the certificates which client trust. Okay, and it is also protected by a password. So we saw in the previous diagram, right? So whenever the server is presenting its certificate to the client goes to its own trust store and verify it. Okay. Now we'll see what is encryption. So encryption is the process of like converting your original message or original text to a form which is like a non-human readable, or you can say non-comprehensible. Okay, uh, which we also called it as ciphertext. Okay, so it's a way to conceal information by altering it so that it appears to be a random data. Now, encryption has there are two types of encryption. One is symmetric and other is asymmetric. Symmetric, we also call it as private key encryption, and asymmetric, we call it as public encryption. We'll see in the further slides what those means. Right? So, what happens in symmetric encryption? So, the process of encryption and decryption is done with the help of same key, whereas in asymmetric encryption, the process of encryption and decryption is done using the different keys. Now, let's understand symmetric encryption using this example. So let's say client application has to send sensitive data to the server application. Now what will client do? Client encrypts this data using a specific key and sends this data to the server application. Now, as the server receives this encrypted data, he will decrypt that particular encrypted data with the help of that particular same key. Okay. Now here we can see the same key is used on both the sides, like while encrypting also and while decrypting also. Thus, this because of this same keys are being used, we call it as symmetric encryption. Okay. So the major drawback we can see here is, so if anyone is who is having access to this key, right, he can decrypt the data. So this key should be kept secret. And there are many different encryption algorithms are available, like DES, AES, and Bluefish. Now let's see asymmetric encryption. So we saw, right, in symmetric encryption, a single key is used on both the sides. But what happens in asymmetric encryption? We have a pair of two keys. One we call it as a public key, and second we call it as a private key. Now the owner keeps the private key as a secret to itself and shares the public key to the others. Okay. Now the data is exchanged between client and server, which is like encrypted or decrypted using this public-private key pair. So in our example, since client wants to send data to the server, so server will generate the pair of two keys, private key and public key. So private key, server will keep it to itself, and public key, he will share it to the client. Okay. So client writes a message, client encrypts that message with the server's public key, and now you can see the encrypted data. Now, as it reaches the server, what will it do? It will decrypt that particular encrypted data with its own private key, and hence you got the original message. Okay. Now, we'll see how the data integrity is achieved using hash or digest. Okay. So let's say client sends a message like order status cancelled. Okay. And okay, first we'll see like, so data integrity. So like data integrity is like ensured using the digest or hash of the data, which is like exchange between this client and server. Okay. And what is this digest or hash? So this digest or hash is created from this data that we wrote, right? Order status cancelled. Okay. And what exactly this hash or digest function takes as an input and what exactly it outputs. So the input of this digest or hash function is the message that we sent, and what it outputs is an irreversible fixed length digest. Okay. So if there is a slight change in this message, the digest would be changed. And once that digest is created, right, it would be something like a random text, right? And if there is any change in the message that we pass, right, the digest will be different for every message. So yeah, this is kind of a one-way digest. Like once it is converted, you cannot like go back. So yeah, this digest cannot be used to recreate the input data. Okay. Now the client creates encrypted data and the digest of the data. Okay, both. So he sends this data, order status cancelled. He encrypts that data using the server's public key. Along with that, now what he is doing, he calculated the digest on this message. Okay, so now he's passing two things. One is the encrypted data along with the digest. Okay. Now let's say in between, like over this communication channel or over this link, intruder application came. Now what it did, since the server public key was accessible over this network, right? So what this intruder application did, he wrote a message like order status approved, okay, and he encrypted that message using the server's public key. Now server received this message, right? But ideally, it should have received this order status cancel, but it is receiving the order status approved. So, like this is totally wrong, right? This should not happen. So now, um, what we can do is that uh, now let's see a scenario like client sends this order status cancelled message. Okay. Um, like how we can overcome this, right? How we can ensure the data integrity. So let's say client sent the same message, order status cancelled. He encrypts that using its public key. Along with that, he calculates the digest. Okay. And now let's say the digest being calculated from this particular message, order status cancelled, is XYZ. Okay. Now we are passing encrypted data along with this XYZ. Now let's say in between intruder application came, right? And he sent as usual order status approved. And he also calculated the digest or the hash, right? Like ABC, and he sent over the network. Now server receives this data, and he decrypts it using its private key, and saw that the message is like message is order status cancelled. But uh, when he calculated the digest, right, he calculated something like ABC, which do not match with the original which client sent, right? So in this way, server uh, got that this message being received from the client, it is not genuine or it is not correct. So in this way, this data integrity is ensured. Okay. We'll see like what is a certificate. So you can also try it out. Like in the URL only, you can see this padlock, right? Um, you can go to this connection is secure, and in this you can see the certificate, right? So in the general tab, you can see this certificate is issued to whom, issued by, and its validity. Okay. In the details section, you can see the signature algorithm being used, SHA, RSA, right? Also, you can see the public key, right? As we saw earlier, right? The public key is wrapped inside the certificate. So we can see here practically. So it is happening. Okay. Along with that, some other info is also there. In the certification part tab, you can see there is a root CA, and also we have like intermediate CA. That is another concept. Like we are not discussing in this. Okay. So yeah. Uh, Further, like we'll move on to our main topic. So whatever we saw, right, those were the like fundamental concepts for this for understanding one-way SSL and two-way SSL. So how one-way SSL executes, like, so we'll see its execution. So let's say the client application makes an secured HTTP call to access the server application resource. Okay. Now, as this server application receives the request from client, so what it will do, it will retrieve its certificate from the key store, and it will send it to the client application. Now, client application gets this certificate. Now it has to verify, right, whether this server is like authentic, genuine or not. So client application gets this certificate and it verifies with the help of its own trust store. So after the successful verification by client of that particular server certificate, right? Also, this server's public certificate, right? It also contains the server public key along with some other information. Okay. So after this verification is successful, the client what it does, client will generate the session key. Now this session key is kind of a random key, we can say. Okay. So after this successful verification, client generates a session key. Now what will client do? Client will encrypt this generated session key with the help of the public key received from the server. Okay. And it will send this encrypted session key to the server application. Now, as the server application receives this encrypted session key, it will decrypt it using its private key. Okay. Now, both server and client has that particular same key, right? Same session key, and hence an encrypted link is established. So in order to summarize this, like what happened during this SSL TLS handshake process, so server presented its certificate to the client, and client verified that certificate, right? And the session key was negotiated. So three things happened. Okay. Now both are having the session keys, right? Session keys. So how the communication will happen after this SSL TLS handshake process? So simply, client will send the data, okay, and it will encrypt it, okay, with the help of that particular session key, okay. And now this server public key is not used for encryption, that session key is being used for encryption. So this is the like point, important point. So client will send the data to server by encrypting this data with the help of session key, and server will like decrypt that particular data with the help of that same session key. So if you observed, right, whatever I like gave info on the one-way SSL, the execution steps. So we like moved from asymmetric encryption where we were having the server's public key and private key, and then we established a like symmetric encryption. We move on to single key, right? That session key. So yeah, this is the point. Really good point. Like we moved from asymmetric encryption to the symmetric encryption. Okay. Uh, yeah. So we'll move on to the demo part. So in order to do this, like how we, in order to configure our Mule application to have one-way SSL, first we need to have certificates being generated. Okay. So as we saw, right, we had the server key store, we had the server trust store, right, and the certificate was being exchanged between from server to client. So three things happened over here. So first we'll create the server key store, which will be having the private key along with the certificate, and this certificate is nothing but a self-signed certificate. Okay, this is not issued by a like a certificate authority or something like that. These are like we are only creating the certificate. So first we'll create the server key store. Now by creating the server key store, what we are creating is the server's private key and the public key. Okay, and which command we are using is this gen key pair, right, which is also like generate key pair command. Okay, and this generated key and the self-signed certificate will be stored in the server key store. Okay, these two things will be stored in key store. Okay, now like let's explore these options being given in this command. Okay, so first we'll see like what is meant by alias. Okay, so we saw that, right, private key and certificate, these are stored as a key store entry. Okay, now this entry is like identified using a unique string, and this unique string we refer to as alias. Okay, so in this in this particular command, like I have given like mule server demo, a simple, okay, any random name I have given. Okay, like very important point to note is like there can be multiple certificates, right, in the same key store. Now how we can so in order to identify the right certificate, right, so that alias is used in the command, so which is used to search the certificate in the key store. If we see further, we have a key algorithm, right? So this key ALG stands for key algorithm, and the algorithm being used to generate this key pair is RSA. Okay, we have a store type over here, and store type, like there are types of key store like JKS, PKCS12. You might have seen, right? This key pass like stands for key password, and this store pass like specify the store key store password. Okay. Next is, once we created the server key store, right, fetch that particular certificate from that key store and bring outside from that key store. So in order to do that, we need to export the server's public certificate from key store. So we are using this export cert command in order to do this. And once being exported, what we will do, we will public certificate into the client's trust store. So whenever the server will send its certificate to the client, it will verify, it will go to its own trust store and it will verify that. Okay, so these are the commands. So Abhishek, are you able to see this Anypoint Studio?
We have not yet shared the Anypoint Studio. I can see only one screen.
Okay, okay. I will share the Anypoint Studio. Okay, you are able to see, right?
Yeah.
Okay, so like in order to save time, I have already done this POC and we'll walk you through this. So, so the important point is in the source messages, we have what we have generated from those commands, right? So we have a server key store and we have the client trust store. Now we'll move on to like how we can configure it. Okay. Now this Mule application is like behaving as a server flow as well as the client flow. So I have included both the flows in one application. So first we'll see the configuration of server flow. Okay. So it is taking time. Yeah. So we'll see the listener configuration, how we have done. So we have set the protocol as HTTPS since we want to establish a secured link, right? Okay. The port I have set it to 8082. Okay. Since this is a server flow and we saw in one-way SSL, we have a server key store. So we will be configuring the key store. So we saw the type, the store type, right? It is JKS. The path is like simply I have given the name. We don't have to give like the whole path to this source main resources folder. It directly fetches. You might have seen like we don't have to give the path when if we have stored some sample JSON files which are being required to set the metadata type. So yeah, in the similar way alias that we have given, right, which is used to uniquely identify the key store entry, then the key password and the store password. Okay. And yeah, this makes this. Okay. This TLS, inside this TLS configuration, you might see like there are these three options. You have to select edit inline. Okay. And then this menu will appear. Okay. So after doing this server flow configuration, what and this transfer message is simply printing this server. Okay. Um, let's move on to the client flow. So this is a simple listener configuration. It is not HTTPS, it is simply HTTP. It is on the port 8081 and there is no, you can see the TLS configuration is not present. Okay. Yeah. The important component is this request component. Here we need to do the configuration. So you can see I am calling that particular flow, this path like server, and inside this configuration you can see the protocol is HTTPS. Since this client application is going to call the server application, so first we will be hitting this client application. Okay? So we'll see in after running. So I have set the protocol to HTTPS, host is localhost and the port is 8082 where I'm going to hit. Okay. Now we saw that client was going to verify that certificate from the trust store, right? So we need to do the trust store configuration. So I have set the part to client trust store. The password is the same as we used in the command and the type is JKS. Okay. So, and in the transfer message, like I'm simply trying to print the payload. So what should be the expected output? It should be like server, right? This server should print. So we will be hitting this. It will call this particular listener and then it will store the payload as server and it will directly print out the payload. Okay. So I will run this.
Shyam, meanwhile it is running. Would you like to take a few questions?
Yeah, sure.
Okay, so there is one question from Virendra. He's asking what all algorithm supports asymmetric encryption.
Mhm.
When will go for this? And what is the best way to select algorithm and mode?
See that about algorithms, right?
Mhm.
So For there are
What
many like encryption algorithms, right? We have
what
a
what all
DES. Yeah.
what all algorithm supports asymmetric encryption? I
I guess
guess
it
all
should
of
be
them.
AES and Blowfish, 3 DES, 3 DES. These all algorithms. I guess.
Okay.
Yeah.
And like, what is the best way to select a algorithm and mode?
Mm, like as far as I don't know like how we can like, select best way. Is there a best way or not? But there should be some parameters, right? Yeah. This algorithm should satisfy this parameters. So there might be this thing.
Maybe
Yeah.
organization specific also, like where they
Mm.
say like we need to use a particular algorithm, correct?
Yeah. Yeah.
Yeah. So Abhishek, add to on this, which
Mm-hmm.
one is the best one is like it's all depends on your inference security team. So they just guide you what algorithm we have to choose. Don't choose any public algorithm that anybody can crack it. So they have to select. Actually select the algorithm that is not encrypted by the. Selections of the best practices is from the security and the infra team. It's not belongs to our development team, so they give us a guidelines on what algorithm we have to use. Okay.
Thanks, Reza.
Yeah. Thanks, Ravi.
And Abhishek or Sham. So
Yeah.
in your real-time project, are you guys using CA signed certificate or self-signed one?
I guess we don't use, right, cells. Like I
Mostly
have
it
a
is CA signed. Mostly we use CA signed only. Shiva, maybe you can answer
We
this.
can use both. We can use both. So self-signed certificate. So let's suppose if you are specific to Cloud Hub, okay. If you're deploying your applications to Cloud Hub, you configure your HTTP listener with or the requester with HTTPS format, right? Now this when you deploy your application, which is an HTTPS application, right, and you deploy it on Cloud Hub, you use self-signed certificate at the moment because that is the mandate for deploying an application, right, to Cloud Hub. But that self-signed certificate is actually not used. If you when you go and deploy that application, the actual certificates which are part of the Cloud Hub domain, they are used at that moment. So for MuleSoft currently on Cloud Hub, you don't do that. I mean, you just upload a self-signed certificate, but they are not actually used. In When it comes to on-premise setup, maybe. So in terms of on-premise setup, also your domain, right, the actual domain which you have taken. Like if I say there is a company which is using, let's suppose Google is using MuleSoft, but the domain still is google.com, right? So the signed certificates and everything they are used at the domain level, not at the application level. Even though if you are deploying an application that might be exposing an HTTPS endpoint, but you just create a dummy signed certificate. That is actually not used. Does it
Yeah,
make sense?
yeah, it makes sense. That's right. Yeah.
Yeah.
So I'm trying to figure out, what's been used at, the project, Sham is working on. Because it's ideally like apply the certificate, be it whether it is self-signed or CA signed.
Hmm.
So it should be in the domain level so that all the application utilize that because
See,
if the certificate.
domain. See, if you're talking about domain is. I mean, what kind of setup you're talking about? Not domain. If are you talking about domain project or you're not talking about just domain?
This domain.
Just domain. Yeah, go ahead.
So, consider a scenario, right? If the certificate changes and we have around 10 to 20 APIs that are running, then
Mhm.
you have to apply the new certificate, all over to the all the APIs that requires downtime and all
Okay,
that.
I got that point. Okay, so yes, you are right. So whenever we do that kind of setup here, where a domain project is there, and then there are multiple applications. So we only do it at the domain level. We don't do it at the application level.
Right, right, right. Yeah. So yeah, yeah, that's what I just asked Shyam. Like,
Okay.
what kind of setup he has in this real-time project?
So I guess Sham currently might be working on any cloud up project where he's only doing at the application level, which basically is never used in actual cloud up traffic.
Yeah.
Right, right,
Correct.
right.
And to the previous question, where we were discussing about your
Algorithm.
cipher suites and algorithms, right? So, I guess, see, we as a company or as a MuleSoft uh, part, or if we consider us to be an organization, so we try to choose those algorithms like compatible, which are compatible with the our vendors, our clients, our partners, or maybe if we are putting it on the, let's suppose Google has their development applications, right, or they are exposing few REST APIs. Now, the algorithms which will be used at the server level, they will be something which are easy to interact first, secure, and they are like accepted worldwide. They have, I mean, of course, there will be standards to it. The best, you can say, set of configuration for not only the algorithms but cipher suites, then digest algorithms, then encryption algorithms, TLS, and everything. It is of the best of the configuration, and it is compatible and accepted worldwide, right? Because you are your audience is huge.
Even you can include digital signature.
Yes, I hope that clears a few things.
And adding to Shiva, like two levels of algorithms we have, and the infra level security algorithm is a different, and
Mhm.
data exchange is different.
Correct.
So the data one is like both the decision, like as per my experience, both the decision is taken from like what actually our infrastructure is adopting, like what they are feel more secure. So that
Hmm.
recommendation we give to the customer, like this is the protocols or standard or best practices we are using, you can adopt it, and then we discuss with them, are you comfortable or in that or not, because this is our protocols to have the integration,
Yes, yes.
because
So if
we Mhm.
sorry to interrupt. So if you have anybody has worked up with a client who has some sort of APIs, let's suppose, which are hosted on their on-prem servers, they are not publicly available. Okay, so then when you go and try to set up the connectivity there, then you will see that they will tell you, they will give you a document telling what protocols they are using, right? They will tell you the cipher suites, which cipher suites are. So, and then there's a list of it. It's not that they are using only one. There will be a list of cipher suites which and protocols which they are accepting. It's not that it is specific to one client. It's like they serve multiple clients, right?
Yep. Yes, that's true.
And of course, infra level. So, of course, if you are an organization, and let's suppose you are an organization with everything on-prem, not cloud-based, okay, which used to be the fashion earlier. So, you will have a public endpoint, or you can say gateway, or where the actual firewall of your infra sits, right? That is the entry point of any traffic which comes from outside. Then that when that firewall will allow the request to come inside the premises, then only things will the connection gets established. Now those algorithms at that firewall level are the most important ones, because they always have to be in consideration. Then only the traffic will reach inside your premise, and then it will route through multiple routers and switches to reach to your application, to your server where your application is deployed.
Agreed. Yep.
Okay, thank
And
you. Yeah, yeah,
yeah,
Vijay.
yeah, just to add a point on top of what Shiva said, this TLS tunneling is not only applicable for HTTP, any other protocol. Let's say doing MQ email and as well as any FTP stuff, it will be possible over that.
Yes, to build any handshaking or securing any other connectors, we can do it. So it is not only for STTP.
See, this is a very interesting topic, and I mean, let's take it from the very base. Try to understand the very base of it. This is my favorite topic, at least. And that is why I'm speaking so much, I guess. So and there is a lot to learn. It involves everything. It will give you insight of not only just using it for your MuleSoft application, but it can, it will include, basically, it can include everything which is part of networking, your subnetting, your masking, your IP addressing, and firewalls, network, lot of things. It will, it will give you a broad insight to things which we generally don't go into, because that is we stick to a lot of things which are more on the code side of MuleSoft rather than how actually these calls are functioning. But this is something which will help you understand and will clarify the bigger picture of the overall network. Because someday when you will design, or when you will try to design these architectures in actual way, uh, I mean, it's like doing just the code and deploying it on cloud or on-premise server is one thing. But when you're designing the overall flow of data, because you will have to deal with not only application security, you will have to deal with data security, then you will have to deal with a lot of other things also in terms of security, networking, how the data will pass through various clients, right? So let's take this topic in that way and try to understand the very basic of it. Try asking as many as questions as possible.
Thank you, Shiva. Okay,
Thank you,
Shyam.
Shiva. Yeah, I'll take it now.
Yeah, your screen become black only
Yeah,
for me. Okay.
you are able to see now, right?
Yeah.
So this application is running. So what we'll do, we'll try to hit it. And the path was client. So if I hit this, you can see the server is like appearing. So between this request component and this listener component, right? Whatever we saw in that diagram, that whole process occurred in between that. So this is about one-way SSL. Now we'll move on to the two-way SSL. Okay. So what happens in two-way SSL? So in one-way SSL, what we saw is like client was like authenticating whether the server was genuine or not, right? In two-way SSL, both client and server authenticate each other. So what happens in two-way SSL is the execution goes like this. Client application makes a secured HTTP call to access the server application resources. And as the server application receives the request from client, it retrieves its certificate from the key store. And inside the key store, you can see there is a server.cer file, right? And that is certificate. Okay. It retrieves that certificate from its key store and sends it to the client. Now, client gets this certificate, and uh, now the next step is to verify that particular certificate, right? So it verifies it with the help of its trust store. Now, after the successful verification happens, uh, client retrieves its own certificate, which was not happening in the earlier case in one-way SSL. Now, client is retrieving its own certificate from its own key store, and it sends it to the server application. Now, server receives the client certificate. Now, it verifies it with the help of its own trust store, right? So once this server verifies the client certificate, then similar thing happens. Like client will generate the session key, okay, which is a random or unique key. He will encrypt that particular session key, right, using the server's public key and sends it to the client, sends it to the server. Server will decrypt that particular key with the help of its own private key. Now both are having the session key exchange between both of them. Okay. So once this as this TLS handshake process occurred, so whenever the data exchange between client and server application will happen, now this data will get encrypted by the session key from one side. It can be from client side or a server side, and it will be decrypted using that particular same session key on the another side. So again, we saw that we moved on from asymmetric encryption, having public private key pair, right, to the symmetric encryption, like using the same key, right? So to like summarize the two SSL, here both client and server application are verifying the certificate and they are authenticating each other. In the one-way SSL, only server was being authenticated by the client, but here both are getting authenticated. Okay. Now, like we'll see the generation of keys and certificates. So here, similarly, we will be having a server key store which was in the like created in the one-way SSL also. Here also we will be having the server key store. Just that now the client key store also will get introduced, right? Then the similar thing, right? Extracting the server's public certificate from server key store, extracting the client's public certificate from the server key store, and then importing them to their respective trust stores, right? Those public certificates are to be put into their servers and client's trust store. So we'll go on to the configuring the Mule application. Okay. So yeah, let me just close this. So yeah, it's kind of
Shyam,
yeah,
stop your older one
yeah,
first.
yeah. So it's kind of a similar flow I have created. So we have two flows, server flow and the client flow. Okay, let me show you the server flow configuration first. So inside this listener, what we will do, it will be secured HTTP protocol. Okay, and while configuring this TLS, earlier there was only key store, right? In case of one-way SSL, now we need to configure the trust store as well. So okay, earlier first I will show you the source main resources. So here you can see we have server key store, its trust store, client trust store, and client key store. Okay, now inside the TLS, see, you can see I have configured the trust store configuration. We have server truststore.jks, its password and the type. Similarly for key store, I have configured. Also, we have given the alias. Okay. Now, in this transform message, simply the server is being uh, stored in the payload. Okay, and this is like a simple HTTP listener, and not a secured HTTP, just for calling purpose. And you can see there is no TLS configuration over here. This is the important component which is going to call this listener. Okay, the path is set to the server, and we'll see the configuration. So it is set to secured HTTP in order to establish that encrypted link between client and server. The port is set to 8082, and earlier in that case, in one-way SSL, we had only configured the trust store, right? But here in this case, since server is also authenticating the client, so it has to fetch from its own key store, right? Client has to fetch from its own key store. So we need to configure the key store as well. So you can see the key store is also being configured. Okay, it's kind of similar configuration. So yeah. So here also the expected output should be this server, right? So let me run this project. Okay, so it is deployed. Now let's move on to this, and I'll just hit it again. Let's see what is the output. So yeah, you can see the output is server. So in short, what happened when this request component got called, it actually hit this, and before actually performing this, like before going to this transfer message, that whole process occurred, like what we saw in this diagram, right? That whole process occurred between that particular request component and that listener. So yeah, this is about two-way SSL. Yeah. Yeah, Abhishek. So yeah, this is like over.
Okay, Shyam, is it possible for you to generate the key like the steps which you have shown maybe
Yeah,
for
sure, sure.
one-way SSL?
I'll do that. I'll do that. So I guess you have pasted those in
Yeah,
the
I have
chat.
given the commands in the chat. Maybe you can also show them once at least for
Yeah,
one way.
yeah. So you are able to see screen, right?
Yes.
Yeah. So first we'll create a key store, server key store. Okay. So you just have to go to this bar and type cmd. Just I'll paste that command. Okay. So you have to enter like the basic details. So here I'm like entering randomly my first name and last name. Okay. Organization I will enter it as a server. And you have to type like it will like give the preview of whatever details you have entered, and then you have to like, type yes. Okay. If it is correct or not. So if you once you click on yes, so you can see the server key store got generated over here, right? After that, so now the server key store is having the private key along with the self-signed certificate, and inside that self-signed certificate, the public key is wrapped inside it. Okay. Now let's extract that public certificate from this server key store. Okay. So we'll use this export cert command. Okay, CMD is open. Just paste it. You can see now the server certificate got extracted from this server key store, right? After the execution of this thing. Okay. Next, we'll import that particular certificate into the client's trust store. So for that, we'll execute the same command.
Are you not providing the expiry of the self sign?
No, no, I'm not providing this. Okay.
Maybe just a general thing. So just to add here, both the key store and trust store are just a terminology. It is just a .jks file. It is just a purpose, we define that.
Yeah, those are the .jks file. Like in order to represent it over a diagram, right? So it's like a carrier thing which is holding those particular keys and certificate, right? You got that right?
Yeah, that's what I'm mentioning. Yeah.
Okay. So yeah, the third step is like uh, importing that particular certificate, right? This server certificate into the client's trust store. Okay. So I have entered this, and you can see this happened, and uh, we have a question like trust this certificate. I'm clicking entering yes, and you can see the certificate was added to this key store. So you can see the client trust store got generated. So this is kind of names I have given. So you can also see in the command, like since I have gave this like client restore.jks, and that's why they got added by this name only. That's why they got created by this name. Yeah. Yeah, this is how you can generate this, and similarly you can replicate for the 2SSL as well. Just that uh, you need to create the client key store, and same you need to export that certificate from the client key store and import it into the client trust store. Yeah. So these
Uh,
things will get added.
Technically, we can use the same file for both key stores and trust store. Sham, when we are doing the mutual assessor.
Uh, Yes, we can use similar file, but as we saw earlier, right, there can be multiple key store entries. So you can, if you are like using multiple entries to the key store, so you can use a different alias name. So
I mean, what I'm
to
saying is
identify, yeah.
the same file will act as a key store as well as trust store.
Same. Sorry, could you please repeat again?
Now, what I'm saying is the same file will act as a key store as well as trust store when you're doing the mutual assessor.
I mean, you are saying for two-way SSL we can use the same. We don't
Yes,
need to
yes,
generate two
yes,
different, correct? Yeah.
yes, yes. Maybe and to add, like, since Sham not covered the CA, so if we are going
Yeah.
for the CA, right? So
Mm-hmm.
probably just to add a pointer, so we generate the certificate signing request. So CA is a general body of authorizing this certificate. So once we issue the CSR to the CA team, the CA team is there are multiple public general body that is probably registered SSL, security SSL. There are a lot of things. So once we send the CSR, they will be generating they will be having the root trusted certificate for their
Mm-hmm.
CA body, and from there they will be, because they will not initiate, issue your SSL certificate directly from the root certificate. They will be issuing a intermediate certificate. It's a chain of certificates. So from intermediate they will be signing you the SSL certificate. So when that the case, you will be adding those certificate into your .jks file.
Hmm. Like I haven't explored on that part, but you are trying to explain this certificate chain, right?
Yes, yes, yes. I'm just giving
Okay.
adding the point here.
Yeah. Thanks. Thanks. So yeah, Abhishek, we are done.
Okay, thank you, Shyam. So we are open for questions now. We have one question from Akhil. What factor determines the type of SSL we use? What factor means you're talking about like the
Yeah.
.js or some other?
No, so basically I'm asking like when to use two-way SSL and when to use one-way SSL.
Okay.
I mean, is
Maybe
it
I can.
Okay, so
that
as
is
far
like
as like I know, it should be like it depends on the authentication, right? Both client and server are being authenticated in two-way SSL, and just server is being getting authenticated in one-way SSL. So if you want both being
Uh,
authenticated, you can use two-way.
so
Maybe I can.
basically what I'm asking is uh, so in which cases we use some real-time is like what determines like we use two-way SSL or one-way SSL.
Akhil, I can answer that. So
Yeah.
it is all about your enterprise architecture. So let's say you're developing an API, right, and you're trying to expose it to the outer world, and it's all about how your API is going to be. Is it a public or the private or a protected? Okay, so when you talk about the protected, you will be ending up with only handful of source system that is going to use your API. So in that case, to double ensure that tunneling is fully encrypted, and you have to know that whatever the source system that is calling your API is valid, as well as the your source system should know that you are the authorized server that they are calling. So that's where it comes with your mutual SSL. But when your API is going public, right, and anybody is can use that. So in that case, you just need to authenticate yourself from the client perspective. That's where you're using the one-way SSL. It's all about where your API lies. See, this is since being a MuleSoft, we are talking about API, but this SSL is a whole generic concept applicable for all other protocols.
Okay. Yeah. Thanks, Vijay.
Thanks, Vijay, to answer that.
Hi
Yeah,
Shyam,
thanks.
I have a question.
Yeah, hi.
Yeah, hi. Can we say that two-way SSL is asymmetric and one-way is symmetric always?
No, we saw, right? We gradually moved from asymmetric to symmetric. So first we were using like servers public key and private key, and then we established like a session key, right? Which
Yes.
was being used for encryption and decryption in the last.
So that
So
was in the two-way SSL, right?
no, in the both, in both we saw, right?
Oh, okay.
So symmetric and asymmetric is a generic terminology, meaning basically when you use a different keys to authorize, it
Mm-hmm.
is asymmetric. When you use the same key to authorize,
Kaja, you're breaking. Like, is it only me or
No, I am able to hear
No,
you.
it's
It's,
good.
it's only for your wish.
sorry, Abhishek.
Yeah.
Now it's audible.
Yeah, yeah, Rajai.
Yeah. So as Akash, sorry, Sham is already explained, right? What is
Mm-hmm.
symmetric? When we authorize or decrypt the things with the same key, okay, it means a symmetric, where we are using the same key for the client and server.
Yeah, got it.
When
So it all based on the like private or
how
public
the
key.
handshake is going on, how they are authorizing to each other, they are using the public or private
Private
stuff or
key,
not.
basically. Yeah.
Okay, so that's
Got
way.
it.
So as per the demo in the one way SSL, we have it both the two flavors, asymmetric also or symmetric as well, right? So he explained when handshake is happening, it's symmetric. They are using a one
Public
session
key.
key, one
Sorry,
session key, right?
private key. Yeah.
When they exchanging the data, they are using different keys.
To add a point here, in a general cryptographic world, symmetric encryption is kind of moved away from the security mechanism. The only suggested standardized method of doing is asymmetric.
Oh, okay. Yeah, thanks.
Thanks,
Just
Vijay and Ravi.
one more thing. So we are not using SSL SSL now. We are using TLS. Is it? Uh,
Yeah, correct.
Yeah, SSL is depreciated.
okay. Now we are using TLS only.
Correct.
Okay. Thank you.
And TLS version should be more than 1 point. It should not be 1.0. It is vulnerable, so it should be 1.1 or 1.2.
Oh, okay. Thanks for the.
Sham, it is a very wonderful session, Sham, actually.
Thanks. Like I haven't explored much on that, but we'll sure explore that certificate chain that you talked about. Right? Like,
Yeah, but whatever you have covered, right? It's pretty
yeah,
much impact, it's very easy for everyone to understand.
thank you.
Thanks for your input, Vijay. Also for Shiva and Vijay to help us to answer the questions. Any more questions?